So, a very warm welcome to everyone. And today we are going to present our PowerPoint presentation based on the simulation and the project given for us. Our project given for us is a microwave oven simulation. It's an embedded related project, and the members of our team are myself, Jason Emmanuel, Harishwar V, and Nattar G, and we are from National Engineering College, Koilpatti, and we are studying in the Department of Electronics and Communication Engineering. Let's move on into the project. So here is a short overview of our project. Our project is moving based on these kind of topics and goals of the internship, project requirements, embedded systems, design of embedded systems, project implementation, and finally we are going to simulate the project in a simulator, and we are going to conclude the project. The goals of our internship is we are going to learn the basic concepts of embedded system and the hardware and software requirement needs to build the embedded system. So basically embedded system is a combination of hardware and software components. So we are going to learn the basic concepts, and we are able to build embedded system on our own using hardware and software. So in this project we can learn how to create a embedded system hardware and embedded system with the embedded system software. And our project requirements our project requirements is based on these things. uh, Basics of embedded system, we need to know about basics of embedded system. C programming, in C programming we have to be specified in these particular topics: data types, array and pointers, and mplab xide. Xe8 is the compiler we have used, and PIC simulator. We need a tactile switch, 16 to 4 character liquid crystal display, and a timer and interrupts. Timer and interrupts needs to be fitted in the microwave oven. First, let's move on to a common introduction of what is an embedded system. An embedded system is a combination of software and hardware components, where software is embedded into the hardware. It is an electronic system that can be programmed based on our needs. So basically, if we pick on our mobile phone, it is also an embedded device, but it is designed for various needs. But a particular embedded device like microwave oven is only designed to heat the food or cook the food. So based on that, the use of the product, we are designing the embedded system. So this is called an embedded system. An embedded system can be used to design any sort of things. If we face any problems in that embedded system, we can also rectify that by changing the architecture and changing the algorithm of the embedded system. So there are a set of protocols where we can organize the way of working and controlling the system. The hardware, where the software is embedded, is built with the help of a microcontroller. So we all know about a microcontroller. A microcontroller is a thing which controls the entire entire thing, that is the hardware thing and the software thing. So the hardware is implemented with the software via the microcontroller, and the microcontroller play a very important role to transfer the informations and also get the inputs, and also for everything in the microcontroller is used. The hardware is comprised of an user interface, which includes the display, input and output interfaces, and memory of the system. When we consider types of embedded system, power supply, processor, and communication ports are needed for the system to function properly. So basically, we know that for a system to communicate and for system to work properly, we need a particular input, a display, and a proper output, which we can get the desired output for us, and for the desired input. And considering the embedded system, we need a power supply. Surely, we need a power supply for any kind of electronic things, and a processor which processes the information, the inputs, and give the desired outputs based on our inputs as a control signals. And communication ports. Communication ports are the major requirements, because if we need to do anything apart from that desired operation, we need communication ports which can help us to communicate with the device, and we can perform certain processes we need. and the need for the system to function properly. So these are all things that are needed for the system to function properly. Based on the performance and functional requirements, embedded systems are classified into four types, like standalone embedded system, real-time embedded system, network embedded system, mobile embedded system. So these are the four types of embedded systems based on the classifications. So based on that four types, we are going to see how we want to select the parameters to choose the embedded system. So choosing parameters is necessary things. First, we have to check about the reliability. Reliability is based on the product you need, because some products need to be very reliable. So cost is a main thing, because the product which you are designing is going to get succeeded or going to get failed, is because the main part goes to cost. The lower the cost, the higher is the success rate of the product. And power consumption, lower the power consumption, higher the efficiency of the product. And the performance is also required. Memory is also required. So in the right side we can see in the right side we can see the factors for selection of the embedded processor. First we can see the cost, speed and performance, optimal power usage, and then peripheral support, advanced processing, and then C programming. The basic things of C program, as we saw earlier, the data types, the arrays, the pointers. These three topics you have to be specified. And like data types, each variable in C has an associated data type. It specifies the types of data that the variables can store, like integer, character, floats, double. Each data type requires different amounts of memory. We can see that if we use an embedded system like a microwave oven, we will give several inputs like time, like how many degree Fahrenheit to cook the food, how many minutes it have to get operated, like that. For that giving input, we use data types. Arrays are used to store multiple values in a single variable. Instead of declaring separate variables for each value, to create an array, define the data type and specify the name of the array followed by square brackets. And then pointers. Pointers are one of the core components of the C programming language. Pointer can be used to store the memory address of the other variables, functions, or even other pointers. And then the main role here, we, we are going to use the microprocessors and microcontrollers. Basically, microprocessor and microcontrollers are like a heart to the disease, because without microprocessor and microcontroller, the communication between the external device and the processor cannot be possible. And in this diagram, you can see that outside still like projections. Those are the peripherals that are going to get connected with the device for performing various tasks. Basically, microprocessor and microcontrollers have certain storages like registers, which are used to store immediate data, and which helps in performing some immediate which is used in performing ALU operations, like that we can use. And we can inside we can see a program counter which helps to fetch the data from the memory. And that data will help us to that data will help us to proceed with the programming further, because once the program counter is loaded with the data, after it moves to the processor to perform the function, next data need to be loaded to for the smooth and sequential operation. For that sequential operation, we are using that. And if we see, there will be several buses. Buses are the components in which buses are the components in which we use different inputs outputs that will be move from one place to another place, like one part of the microprocessor to another part of the microprocessor and to the outer surface. With this, we use flag flip-flops inside the microprocessor, accumulators, and everything for storing the data. And we need to give a clock signal to operate the microprocessor. Um, Basically, the microprocessor needs ALU unit, and it also needs a decoder and encoders. As encoding unit that will be decode the instruction given by us to the language that the microprocessors can understand, and it will encode that. And instruction resistance also play a very important role here. The inputs can be both serial and also parallel based on our need. And then we use increment decrement for all functions. We use that. Next, we can see that MATLAB X and IDE and PIC simulator. So it is a similar real-time emulator for development board which integrates MPLA, BS, and AVR, JPD debuggers. PIC SimLab supports some PIC for microprocessors and for some microcontrollers. Like it have integrated Arduino with it, so that we can perform specific tasks. So from here, Harishwar will take care of the process.
Hi, myself Hariswar. I'm going to take the further slides. PIC 16F877A. The PIC microcontroller PIC 16F877A is one of the most renowned microcontrollers in the industry. This microcontroller is very convenient to use. The coding or programming of this controller is also easier. One of the main advantages is that it can be read erase as many times as possible because it uses flash memory technology. It has a total number of 40 pins and there are 33 pins for input and output. And then we are also using that tactile switch. A tactile switch is one of the type widely used switch that completes an electrical circuit typically when pressure is applied to the device by the user, which then gives the user a perceptibly click or haptic bump in response, in indicating current flow. Next one, CLCD. CLCD stands for Character Liquid Crystal Display. In PIC SimLab simulator, there are two types of displays. 16 cross 2 display one, and then next one is 16 cross 4 display. This is used, we are using this in this project. There are two kind of communication modes. They are one is 4-bit mode and the another one is 8-bit mode. Here we are using that in our project. You use the 8-bit mode only. Another one is the timers and the interrupts. We are also familiar with this timers and interrupts. Here the PIC microcontroller chip PIC 16F877A has three different timer modules. They are listed down below. Timer 0, timer 1, timer 2. PIC microcontroller consists of both hardware as well as the software interrupts. If the interrupts are generated by external hardware at certain pins of microcontroller or by inbuilt devices like timer, they are called hardware interrupts. While software interrupts are generated by a piece of code in a program, also known as external and internal interrupts. Project design. This is our how we design the project. Micro oven. This is a project we have taken. In micro oven project are machines that are used to heat the food using electromagnetic waves. We are using this kind of electromagnetic waves to use electromagnetic waves to heat that micro ovens. So by using of the electromagnetic waves, this the name is derived from is a micro oven. These machines work in four different modes, namely micro mode, grill mode, conventional mode, start mode. First, we're going to see about micro mode. That is used for traditional cooking. Uses maximum power of 900 watt. And then grill mode, used to cook meat. User could set their time according to the meat used. And then third one is convection mode. It uses 3 minutes to preheat the oven to user defined temperature. And then final one thing is start mode. It uses a default time of 30 seconds. Here I'm going to conclude this session with the last slide of session conclusion is, thus we made the micro oven simulation using MP Lab X IDE, PIC SimLab and the XC8 compiler, and the basic concept of embedded systems and C programming. Thank you. Now the further simulation will be explained by Natar. He will explain the simulation step by step.
Now I'm going to explain the project presentation of a microwave oven. And now that first that a cooking mode function, and there are many sub functions. Many of the operation calls are declared that and microwave and convection modes, and the convection mode, and the many of the subters, and that power on screen, and which you can use to display that characters. And next a clear display, which is used to clear that all that elements present in that LCD display, that CLCD, which can erase every characters present in that LCD. And next that set time, which is basically a timer function, which will calculate that time between that two events. And next door status function, and we have time delayed time display function, and we have set temperature, and here we can set the maximum temperature as 250. So this is our wish. We can may change by our wish. I have set it as a 250 as a maximum temperature in the Celsius form to heat that microwave. And this is my whole logic of that program. Now I can run that program, and that build successful command is set produce reset output, and will create a hex file format. We can extract the hex file in a PIC SimLab file load hex, and we can select the PIC changes as a PIC 16F877A, which is basically a microcontroller. Here we used this microcontroller, 8-bit controller, and this is clock frequency, heater and cooler unit, heater and which is our inbuilt peripherals in that 68878. And to load hex, and we are go to file, and we have choose that particular function and select that hex file from that file. Now select that. Yeah, now the hex file is uh, loaded, and then the powering is on. The micro, there show modes: micro, grill, convection. And first select the micro mode, and that shows that the how the power is set, the maximum power consumed. And next, so the timer in the minutes and seconds. Here can wish we can, and I give where we can give the maximum of 60 minutes, 59 minutes 59 seconds, and we can demonstrate as I can declare as some small amount of time. We, by that is a hash symbol which is used to clear that. You want to clear that, press that. Now now I press a 10, and to enter that we can press a hash symbol. If we enter that, the fan is rotating and the time is decreasing. And this is the started the microwave generation, and it is started to heat. After the time is finished, the fan is turned and the heat has been generated. Then now the cooking time is up. After the ending the time, the cooking the time is up is a command is produced, and two is a grill mode, which is basically operation of a micro mode. Both it not use a 900 watts power, it uses a minimum number, so we have to put a 6 seconds. If we can pause, resume the time consumed by using that 5, that push button switch. Now the cooking time is up. It's up and show that main. And next is a convection. The number is 3, and it is basically used to preheat that particular food. It asking that temperature. Now if I enter more than the, but maximum limit is a 250, and this is a invalid temperature. So we want to I said earlier that the maximum temperature is at 250. So we can enter that below 250. Now I can set to that 100 temperature, and that heating time. Now the preheating started from 50 seconds. The time remaining is 50 seconds. The time to increase the speed, I am varying the clock speed, so it will very faster, and we will now go to the next operation. And the time, it's a preheating process in the convection mode. You can notice the difference in that speed. By increasing the clock frequency, the time will be, the consume will be less, and it basically represents that baud rate, and it's basically denotes a communication between the two. Now the time is up. And I enter the another time, clear that by using star, and by changing that 10 megahertz frequency, and hex file is loaded hex,